So in this video, we're going to find the derivatives of the inverse trigonometric functions. And I know whenever we hear the word trig or trigonometric functions, we kind of just want to go and hide. Brings bad memories. And it gets even worse whenever we hear the word inverse trigonometric functions. We kind of just want to die. But we actually don't have to do either, because the derivatives of inverse trigonometric functions are actually going to be simpler to compute than derivatives of the regular trigonometric functions. And let's see how. So here we have that the 3C's rule also applies to inverse trigonometric functions. And if we remember from the regular trig functions, the derivative of all functions that start with a C is negative. So the same rule applies. And we're going to do that in red. And it's going to say that the derivative is negative. Now, there's a little twist here in notation that we're going to have whenever we're computing these derivatives or introducing the rules, that we're going to have a du over dx. And that is going to be right here and at the end of every derivative rule that we're going to see. And that refers to the derivative of the angle, right? And whenever I talk about the angle of a function or the angle of a trig function, it is going to be the inside of the parentheses, right? So I'm talking about the inside of the parentheses. So this right here is the angle, right? The angle is going to be u. So if we go to our three functions that are start with the C, our 3C's rule, it applies to cosine, cotangent, and cosecant, right? In this case, it's going to apply to inverse cosine, inverse cotangent, and inverse cosecant. And the derivatives are going to be negative as well, right? So nothing has changed from the 3C's rule. The derivatives of the functions that start with the C are also negative. So now the derivatives, though, are going to be a little more complicated in the sense that they're a little different. They're not just another function, right? They actually have some algebra going into them. So here the derivative of an inverse of an inverse cosine is going to be 1 over the square root of 1 minus u squared, right? And u squared being the angle or the inside of the parentheses, right? So it's a C function, so it's going to be negative, and it's going to be 1 over the square root of 1 minus u squared. Now, there is something that makes all these derivatives different, right? So the cosine inverse is a number or a constant minus a variable. So here we have 1 minus u squared, right? However, when we go look at the cotangent, right, the derivative of the cotangent is going to be a negative because it starts with a C, and it's going to be 1 over 1 plus a variable squared, right? So the idea here is that whenever we have a number minus the variable squared, it's going to be a cosine, right? So 1 minus variable squared is cosine. 1 plus cosine squared is going to be the cotangent. So 1 plus variable squared is going to be the cotangent. And the last thing is going to be the cosecant, right? And it's going to be 1 over the square root of a variable squared minus 1, right? So you see how this is actually the opposite of the cosine, because the cosine is a number minus a variable squared. Here in the cosecant is going to be a variable squared minus 1. So you see how it's different? And the cotangent is just different overall because it's 1 plus and it has no radical. So that's the difference between the three functions. And also the cosecant has this extra u in front of it, extra absolute value of u in front of it, that we're going to throw in the front. Okay? And all these three functions, what they actually do have in common, what their derivatives have in common, is this du over dx, which is going to be the derivative of the inside of that angle. So if you're just given a simple function, you're not going to have du over dx. And we'll see what that means in just a second. Now let's jump to the next set of derivatives, right? Which are, if you guys notice, they're exactly the same as its married function, right? So cosine and sine are married to each other. We established that in the last video when we talked about sine and cosine being married to each other. So the derivatives are exactly the same. The only difference is that sine doesn't start with a C, so the derivative is positive, right? So once again, an inverse sine function is 1 divided by the square root of a number minus a variable squared. So 1 minus variable squared is going to be an inverse sine function, or the cosine function, the inverse cosine function, except that it has a negative. So now with the tangent, it's going to be exactly like the cotangent, except that it's going to be positive because it doesn't start with a c. And tangent is 1 over 1 plus a variable squared, or angle squared. And now the secant is the last one, and it's going to be exactly like the cosecant, except that it's positive. And secant, again, it's opposite of the sine, right? It's opposite of the sine because the sine is 1 minus a variable squared, while the secant is a variable minus 1 squared. It's the opposite. And we always have this absolute value of the angle just slapped in the front of it for the secant or for the cosecant, because they're exactly the same, except for the sine. And you guys do know that we have the derivative, this du over dx, and the best way to explain this du over dx is just by jumping into an example, because all these variables just seem way too much like the textbook, and I don't like them. I want to go ahead and do some practice problems, some example, and we can see how we can apply all these boring rules into some action. So let me go ahead and give you y is equal to 2 sine inverse of x, and I'm going to ask you to derive that. So when I ask you to derive that, I'm just going to take the derivative. I'm going to take out this sine outside, this 2 outside, and I'm just going to take the derivative of my sine inverse, my inverse sine function. So what I'm going to do is I'm going to go back and be like, okay, the sine inverse of x starts with a c. It does not start with a c, it starts with an s. So it's not negative, it's positive. That goes with our 3c's rule. And then the next part is going to be like, okay, what is the rule of this? So we said that sine of x is actually right here, right? It's 1 divided by the square root of 1, nothing there changes, minus u squared. So what is u, right? I'm going to tell you guys that u is the angle of the function, and in this case our u is just x, so it's going to be x, right? So let's go ahead and write that over here, that u is equal to x, right? Now that's going to go with our du part. You guys see how we have a du over dx? If we have to compute du over dx, that is just asking us to find the derivative of u, which in this case is just 1. So we're going to go ahead and multiply this by 1, which is going to make no difference to our answer, right? So that's the idea of the du. We identify the angle, and we make sure that at the end we multiply by the derivative of our angle, which we call it du over dx, because our angle is u. Alright? So our final answer, we just kind of clean this up, leave it in red, is going to be this 2, this 1, and this 1 are going to multiply, and that is just going to give me 2 on the top. And then I'm going to have radical of 1 minus this x squared is going to be x squared. And I'm just going to leave it just like that. And I have computed my derivative of an inverse trig function. Now I'm going to go ahead and do example 2, which is going to be a little different. So let's go ahead and derive this. So I'm going to have y inverse, I'm going to have y prime is equal to, what is the derivative of 2x? Okay, we use our coefficient rule. That is going to give us 2 plus the derivative of tangent inverse of x cubed. So tangent, the first thing we ask ourselves is positive or negative? Does tangent start with a c? Nope, it starts with a t, so therefore our derivative is positive. Then let's go and look into our rules. Derivative of tangent is 1 over 1 plus u squared. Okay, so I'm going to go ahead and just write what I know, which is just, it's just going to be 1 over 1 plus u squared, right? And in this case, my u is going to be the inside of the angle, the inside of the parentheses. So my u is equal to x cubed. And you guys see how I keep putting the u here on the side. I'm identifying my u, but eventually you guys will be so good at this that you guys just don't have to put the u on the side, and you're just going to do it on your own. It's going to be automatic. So I'm going to put my u in here, so it's going to be x cubed in there. Okay, my x cubed is going to be in there. And then if you guys remember, we're not done because we still have this du over dx, which means that we're going to take the derivative of the angle, du over dx, I'm just going to take the derivative of the angle, or I'm just going to go ahead and take the derivative of u, which is going to be 3x squared. And I'm going to multiply here by the derivative of my angle, which is going to be 3x squared. And now when I clean up my derivative, it's going to be y prime is equal to 2 plus the numerator here is going to join this 3x squared and this 1, which is going to give me 3x squared. And now in the denominator, I'm going to have 1 plus. I'm going to simplify here this x cubed with this square. They're going to multiply, and they're going to give me x to the 6. And now I've cleaned up my derivative to be 3x squared over 1 plus x to the 6. Alright? So I just kind of keep using my rules, and eventually we'll do so much practice on this that you guys will just memorize them and not have to refer back to the chart. But for right now, it's okay to just go back to the chart and make sure we dissect every little piece of these derivatives, right? So let's go ahead and do example C, in which we get to derive an inverse secant function, right? An inverse secant function. So I'm going to go ahead and do that by just jumping straight into it. Derivative of secant inverse, right? So secant inverse is right over here, right? And the way I start off my secant inverse is by doing 1 over the absolute value of u, which u in this case, right? U in this case is going to be cosine, right? So I'm just going to go ahead and put a cosine here. Absolute value of cosine. Let's go ahead and do that. Now we're going to have the square root of u squared minus 1. So u squared minus 1. And what is u? I have it right here on the side. U is cosine. So I'm going to have cosine of x squared minus 1. And I am not done because I still have this part here that I have my du over of dx. So I always have to find my d over dx, and after I do that, I multiply times my answer, and I can say that I'm done. But not until I have my du over dx, I can say that I'm done. So I'm going to go ahead and derive this. And the derivative of cosine is, see, cosine starts with a c, so it's going to be a negative derivative, and cosine is married to sine of x. So it's going to be negative sine of x. So I'm going to have this whole thing here multiplied by, kind of low in space. I'm going to go ahead and rewrite it in the bottom. I'm going to go ahead and rewrite this. Y prime is equal to 1 over absolute value of cosine times the square root of cosine squared of x minus 1 times my derivative, which was negative sine of x. Alright? And what I'm going to go ahead and do to simplify my answer is I'm going to bring this sine of x here to the top, in which I'm going to have y prime is equal to negative sine of x cosine of x and my absolute value and my square root of cosine. Okay? And one minor detail that I did actually without going over it, which is the fact that I went from my squared being out here to my squared being in here. And I can do that freely. I can move the square from outside of the whole parentheses to just being in there between the cosine and the x, right? I can go ahead and do that freely. But whenever we go derive, we make sure to put the exponent outside, right? So to derive, we like this one, but to leave it simplified and to give our derivative, we like the bottom one right here. Okay? So let's go ahead and do the last example, and that's going to be y equal to the square root of cosine inverse of x. So the first step here is that we run into a problem which we spoke about earlier when we started talking about derivatives, which we like to call the, let's see if you guys remember, the radical problem, right? So here we have the radical problem. So whenever we have the radical problem, we get rid of it by getting rid of the radical. So that is exactly what we're going to do. We're going to go ahead and get rid of the radical by having y is equal to, radical of anything is equal to that anything to the 1/2. So it's going to be parentheses to the 1/2 of cosine inverse of x. So you guys see here how we have a baby function, right? A baby function raised to a power. So when we're asked to derive this, we're asked to do a we have to do a chain rule, which has inside of it has an inverse trig function. So you guys see how we're mixing things here together. So we're going to go ahead and do that. We're going to go ahead and start our chain rule by bringing down the 1/2, right? We're going to peel the onion with the outside layer of the 1/2 coming down. That's the outside function we're deriving. So for right now, we don't care about the inside. We're going to bring down the 1/2. Subtract 1 from the 1/2, doing the power rule on the parentheses. That's going to be negative 1/2. And now we're going to take our finger away from the parentheses and be like, oh, we have a cosine inverse of x in there. Okay. Let's put it back in there. And now we need to multiply it by the derivative of cosine inverse. So now, whenever we take derivatives of trigs, we always ask ourselves, trigs or inverse trigs, doesn't matter, we ask ourselves, is this function negative? Is this derivative of this function negative? And the only way to answer that is by looking at the first letter of the function. Does this function start with a C? Yes, cosine does start with a C. Okay? Therefore, we're going to go ahead and have a negative derivative. Our derivative is going to be negative. And the derivative of cosine inverse, if we go back up here, is going to be, apart from being negative, which we already talked about, it's going to be 1 over, I actually want to put the negative up here. So negative 1 over, so square root of 1 minus u squared. But what is u in this case? U in this case is just x, right? So u is just equal to x. So we kind of have like a boring u, right? It's very simple. We just have x. And then remember that we always finish our inverse trig derivatives by multiplying by du. So let's go ahead and find du over dx. So du over dx is derivative of u, which is the derivative of x, which gives us 1. So we're multiplying by 1. So making no difference to our answer because the angle was a boring angle. It was just x. It wasn't a nice fun angle like x cubed or 7x or 5x or anything like that. So now the last part is we're going to go ahead and simplify all this stuff. So when we look across our problem, we do not like this negative fraction exponent. It's just going to piss us off, and we're going to go ahead and fix it. So we're going to go ahead and clean this up by having, let's have just one big fraction line, right? I'll go ahead and take away this line from there. This 1 here is going to come up here. Now if you guys see, I'm going to have a 1 times negative 1 times a 1. So it's going to give me a total of a negative 1 for my constant on my numerator. And now I'm going to bring down this cosine inverse down to the bottom. So I'm going to have cosine inverse of x, the whole thing, to the 1/2, right? And now it's going to be multiplied by this radical of 1 minus x squared. And I have nothing else, right? I just have a lonely negative 1 on the top and I have this giant denominator. And that's okay. That's okay because I'm going to go ahead and do one last simplification of going from this fraction exponent, which we don't like. We don't like having fractions in our... We don't like having fraction exponents in our final answer when we compute the derivative. So we're going to go ahead and change that. So we know that we just have a negative 1 on the top, and then we're just going to have a 2. This whole thing is going to turn into a radical of cosine inverse of x times another radical here of 1 minus x squared. And we're done. And we're done with our derivative for this problem. So if you guys see, the derivatives of the inverse trig functions wasn't as painful because they're actually the same except for the sign, right? So we're actually only having to memorize 3 rules. We have to play around with 3 rules and just ask ourselves, is it positive or negative based on the first letter of the function, right? So on that part, it's a little easier. than the regular trigonometric functions, but the hard part is that we're actually doing a little more by having all these 1 over radical of something, right? Whether variable minus number or number minus variable, right? So that's going to be the difference that makes it a little tougher. But the actual rules, there's less of them to remember. So now let's go ahead and do some practice problems so we can go ahead and master inverse trig functions.